Hello everyone. Today we are going to discuss one SQL question where we need to print the tree structure using SQL query. So let's discuss how our input look like. We have this input in the form of tabular structure, obviously, but to better understand it, we have this tree diagram over here where we can see that one is a root node, one have two child, which is 2 and 3. Again, two have two child, which is 4 and 5. Here you will notice that 3, 4, and 5, they do not have any children. So that's why they are leaf node. And this is what we need in our output. 3, 4, and 5, they are our leaf node. 1 is our root node. And 2 is also having a parent. And at the same time, it also have childs. So 2 will be our inner node. So this is the output we want from this input table. Now, we will try to solve this problem with two different approaches. In first approach, we will not use any kind of a join. In the second approach, we will use self-join. Okay. So let's try to understand it. In order to solve this problem, I need to identify three different kind of a node. One is a root node, another is a inner node, and the last one is a leaf node, right? So in order to identify them, let's analyze the input carefully. If you will see that in input, we have one ID and one p.id. Okay, ID is denoting this number and p.id is denoting the parent. So for one, you will see that we do not have any parent, and that's why we have null in the parent ID. So this will itself become our main condition in order to identify a root node where p.id is null. Then in that condition, it will directly give me the root node, which is 1 in our case. Now we need to identify what can be the condition for inner node. Let's take an example of 2. If that ID is present in this p.id column or not. If we will scan the table, we will see that yes, it is indeed present. And it is giving us the information that 2 is a parent of 4. And again, 2 is a parent of 5, which is again correct as per the diagram. So we will use the same condition in SQL where ID, I'm talking about this ID, let's say ID equal to 2, where ID in p.id, right? So what I'm trying to check if this ID equal to 2 is present inside this column or not. Okay, but you cannot simply write it like this, because if you will write it like this, it will try to compare one ID with its corresponding p.id. Okay, and we do not want that because that condition will never match. You cannot be your parent, right? What do we want is we want to check one ID with each and every p.id if it is present in that set or not. So we will have to write over here select p.id from tree. So we need to use a subquery over here. This subquery will give me all the parent ID. If I am present in the parent ID, that means I am parent of someone, right? So that's the condition we are trying to use over here. Now, do you think it will be wiser to compare this 2 with every occurrence of 2 in the parent ID column? No, right? Even though if he is a parent of a single child, he is a parent. It does not matter if he is a parent of 1 or 5. We just want to know if he is a parent or not. So in this case, it will not be wise to do this comparison with each and every record. So what we will do, instead of select PID, I will write over here distinct of PID. Even if you will not use distinct over here, it will again give you the same output. That's not a problem. But just imagine that we have 1 million records, and out of those 1 million record, we have only 5k parents. That means these 5k values are getting duplicated for 1 million times. Now tell me one thing. Would you want to compare this ID with 1 million record, or would you want to compare this ID with 5k record? Obviously, the condition where we will keep 5k record, that condition will run much faster rather than comparing 1 million record. So that's why it is a best practice to include a distinct over here, right? We should not consider the case that, okay, we have only 5 element in our input. It doesn't matter if we will keep a distinct over here or not. We have to think in a broader way. Now let's talk about leaf node condition. So whatever conditions I have written over here, these are nothing but case when condition. So I will replace this where with when. And as you know that in case when condition, if first condition have not met, then the control will go to the second condition. And if second condition have not met, then the control will go to the third condition. In our case, we have total 3 conditions to check. So for leaf node, you do not have to write any other condition. It will become your default condition. So this is the 3 conditions which we are going to use in our SQL query. Let's go to SQL Server and try to run this query. Okay. Let me run 2 query. First, we will print the content of our main table, and then second, we will print the content of our main query. So let me run it. And this is how it look like. Okay. So we need to print root for 1, inner for 2, and leaf node for 3 and 4 and 5. Let's go one by one. Okay. So I have this case condition where I am trying to identify the type of node. Okay. And I have 3 conditions over here. First condition is for root node. Second condition is for inner node. And the default condition is for leaf node. Okay. So let's start with the first condition. As we have already discussed that for root node, the condition is straightforward. If one person does not have any parent, that means he is a root node. So we have written the same condition over here. When parent ID is null, then that means that is a root node. So our first condition is fine. So for inner node, what we have discussed, if the ID, let's take an example of 2 again. If this ID 2 is present in p.id column, that means this person is itself a parent. Let's take an example of 3. We will check if this 3 is present in p.id column or not. And here we can see that it is not present. Similarly for 4 and 5. And that's why they will be our leaf node. And they will go into our else condition. So that's what we have mentioned for inner. If this ID equal to let's say 2, if it is present in the distinct values of this p.id of our tree table, then it is an inner. Otherwise, the default condition is leaf condition. If I will run it, I will get the desired output. Okay, so this was the first solution where we have not used any join. Now we will discuss the self join. Before discussing the main query, let's discuss another query where I have used the self join, but I am printing each and every column. Okay, so tree has been joined on the basis of tree, but ID of first table is getting joined with parent ID of another table. I will explain you how we have done it. So here I have copy pasted tree table 2 times. Okay, for the first table we will treat it as a parent table, and the second table we will treat it as a child table. So here what we want to do is we want to join ID column of the parent table with the parent ID of our child table. So if we will do this, then what we will get? Let's take an example of 1 only. This 1 will get joined with this particular record, and again it will get joined with this second record, right? So finally what I will get? I will get 1 null from my left hand side table, and from right hand side table I will get 2 1, right, for this record. Again I will get 1 null from my left hand side table, and from right hand side table I will get 3 1, this one. Okay, so that means this 1 is a parent of 2, and again 1 is a parent of 3. Now let's see how the complete result will look like when we will do a self join. I have copy pasted the output 2 times because we need to discuss 3 different conditions. One for root, another one is for inner, and the last one is for leaf node. Let's try to identify a pattern for root node. Here the first 2 columns are for parent, the second 2 columns are for child. Here you will see that whenever the PID of a parent table is null, that is giving me a root condition. So I will write it like this, where parent PID is null. That means that particular node is a root node. Okay, so we have understood the root node condition. Let's try to figure out the inner condition. Okay, so this is very simple. If you have some parent and at the same time you have a child, that means you are an inner node. So we will use the same rule. If parent.pid is not null, that means you have a parent. And at the same time, if you have some child, that means you are an inner node. In our case, the second condition will be and child.id is not null. That means you have some child also. In that case, you are nothing but an inner node. And similarly for leaf node, you can have a condition. If your child.id, right, c.id is null, that means you do not have any child. As simple as that. Now you are a leaf node. So we're going to use the same logic in our query and see how it's going to work. Okay, let me go back to the query. So this is the query we have, where we have done the self join with the tree on the basis of parent ID and child parent ID, which we have mentioned over here, right? We have joined the parent ID with the child parent ID. Okay. Now we have mentioned whenever the parent ID is null, then it will be a root node. This is what we have discussed over here. Whenever the parent PID it is null, right? Just focus on first 2 lines. If it is null, then that will be a root node. This is what we have mentioned over here. Second condition I mentioned for leaf node. Okay, leaf node condition was very simple. If your child ID is null, let's focus on the ID equal to 3 and 4. If your child ID is null, that means you do not have any child. And if you do not have any child, that means you are a leaf node. That's the same thing we have mentioned over here. If the child ID is null, then you are a leaf node. And for inner, it will become our default condition. We do not have to write this much of a code. We can simply write as inner. Okay, now let me try to run it. And here you will see that it is giving me some duplicate record. And why it is giving duplicate? Because here you can see that 1 is a parent of 2 child, right? 2 and 3. That's why as part of self join, it has created 2 different rows for ID equal to 1. We do not want duplicate in our output. So you can just write distinct over here and run it again. And this time it will give you the correct output. So that's it, guys. Now you can ask me why you have explained self join when it was easily achieved without using a self join. The reason behind that is self join is one of the confusing join in SQL, at least for me. And I do not want other people to get confused. That's why whenever I get an opportunity to explain self join, I take that opportunity. And the second reason is I want to give you a different perspective of solving one question, right? There can be different ways of solving one question. Third reason is sometimes deliberately interviewer want to give you a problem statement which will involve self join. Because as I have told you, most of the candidate gets confused over here, and that's what interviewer want. I do not want you to get confused in interview, and that's why I have given you this perspective. Now the fourth reason is I want to ask you one question. Out of these two queries, which one will be optimized one? If you know the answer, then tell me in the comment section. And that's it for this video, guys. If you like this video, then subscribe my channel. I'll meet you in the next video. Till then, keep learning, take care, and bye-bye.